I'm always tempted to go, yo, but I'm not allowed to do that. So I'm going to say, g'day, folks, and welcome. It's Friday Lunch and Learn. Once again, we're committed to doing Friday Lunch and Learn. We're keeping it and keeping the trend going, which is great. We're continuing on our learning journey for Microsoft Fabric. It's really good so far. I really like it. I really like it. It's doing all the things that I want it to do. Hasn't broken too much. It's a bit janky in places, which we find out, and I'm sure we'll run into some things. And we're doing some fun stuff now. We've gotten through data lakehousing. We've gotten through data warehousing. Now we're going to talk about the data science end-to-end scenario. So this is it. So we've got our lakehouse or warehouse sitting here on the left. We're going to use notebooks to clean and prepare some data. We're going to store our data in our lakehouses, looks like. But then we want to train, test, and apply using models and experiments. So it's going to be interesting to see how we do that. I'm interested to learn in this session about Gusto, query language. Hopefully we've got some KQL happening because that would be interesting. If we don't learn it this week, we might learn it next week in the real time one. But hoping, and then also how Fabric interacts with the ML tools, whether that's Azure ML or whatever they've got going on here. I don't know, it might be AI Builder or something. I'm not exactly sure what they call the ML scenarios in Fabric. So we're going to learn that today. That'll be fun. I've got a tutorial as always. The tutorial is here. I'm going to paste it in the chat for those of you that are in the meeting. And I reckon we just jump straight into it. I don't have any extra bits and pieces or any digressions like we usually do. I don't have anything new, but I'm sure we'll come up with something as we go. We always do. Cool. So when we talk about data science, data science projects, they run through a bit of they've got their own process. So that process is starting out with understanding the business, getting some data, exploring, cleansing, and preparation and visualization of the data, training a model, experiment tracking, and then scoring and generating insights, right? So this is when we say data science, we really are talking about ML or AI or whatever people want to call it. But I think ML is probably the most appropriate name for it in this scenario. And so we need to run through each one of these kind of areas. So we're going to be using Fabric notebooks for data science scenarios. We're going to be ingesting data into the Fabric Lakehouse using Spark. We're going to be loading data from the Lakehouse Delta tables, which is nice. Cleaning and transforming data using Spark. So we've done a lot of this in the past thing. So we rehashing over a couple of the different things that we've already done. But then we'll be creating an experiment and running to train a machine learning model, and that's the bit that we're really interested in here. And then figuring out how to use MLflow and the Fabric UI, which is kind of cool. So we've got our architecture up on the screen right now. The first thing we need to do is connect to some data, and then we'll get into the ML scenario a bit later. So let's get ready to get set up. So what kind of prerequisites do I need? I need Microsoft Fabric, and I need an existing lakehouse. Okay, I'll create a lakehouse for it. We're going to use the New York Taxi Limousine Yellow dataset. Hooray, I love the New York Taxi dataset. It's fun. It's very large. And we're going to import the notebook files. Okay.
Can't see your screen, by the way, Greg. We still see the data science scenario.
Not sure. No, yeah, sorry, I haven't changed my screen. I was just reading ahead a little bit so that I knew what was happening. It looks like what I need to do is just set up my lakehouse. All right, cool. Let's go to Power BI. Oh, look at this old report. This is a sample report. I brought it up because I didn't want to have some other report on. Right, so let's create a new workspace. We'll call this the data science demo workspace. It's going to be a Fabric workspace. We're in trial. That's the Fabric trial. we're going to create a new lakehouse. Down here, show all. We've done this in the previous video, so I won't spend too much time talking about it. New lakehouse. Now, what should the lakehouse be called? What do they call it in their thing? I don't think they've got a specific name for the lakehouse, but I feel like it probably should be. What do they call their lakehouse? DS Lakehouse. So I'm going to call it DS Lakehouse as well, because then hopefully I don't have to rewrite the code if they ever refer to the lakehouse. All right, I'm getting myself. I've got the samples already downloaded, I think. Man, this is a heaps more complicated thing. Let me find my samples. This is me being entirely super organized. Okay, so what we have to do is open an existing notebook. Oh, sorry, bring in a new notebook. Copy this code.
Greg, you're on mute.
Somehow I got muted. Sorry about that. Let me do this. And that way I mute everybody else. Thank you for that. This is a large data set, so it's potentially going to take a little bit of time to run through. We're only bringing 1 year of the data set in, but it'll be interesting to see how long this takes. Okay, we're just using anonymous access. Yep. Okay, that worked. So we set our Spark configurations, which sets us up for optimized writing. That's what these 2 lines do. So this is just configuration stuff. And then we're going to use a data frame to save the data into the lakehouse to a table named MYC taxi raw. So that's what the next piece of code is going to do. So we create a table name MYC taxi raw, and then we do a df.write on this table name, and then hopefully it will just work. So let's see. Run, 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 run. So at the end of this, as we learned in our lakehouse session, is that we can refresh this lakehouse and have a look, and we should be able to see the table sitting in the lakehouse. So we're pulling this data down from the blob storage. So that's what the first session does. It goes and gets data in a particular location. It's all parameterized so that you can iterate over several years or whatever if you wanted to. The second piece sets us up for write. And then the third one is actually taking that data from the first one and writing it into this new table called NYC taxi underwater score raw. All right, that works. Hold music for a while. It's been running for 50 seconds. I do like Spark. It's kind of got, it tells you how long things run for in milliseconds. I'm going to open up my zoom it as well so I can zoom on stuff. Okay. Zoom test correct. All right, no worries. There we go. Running, still running. Minute 31. It's going to be interesting to see how many lines this has got. Okay, so we are going to use a Python while that's still running. We're going to use a Python data visualization library called Seaborn. Does anybody know Seaborn? Have you heard of Seaborn before?
Yeah.
Here's some information about it.
Seaborns usually give some additional like coloring and stuff like that. So usually use it in addition to like matplotlib and stuff like that. It's less common, but it's good.
Yeah. Okay, cool. So what we're going to do is we're going to take that data. Once that data is loaded, we're going to load it from our delta table, which is what's being generated now. We're going to create a random sample of the frame, convert that Spark data frame to a pandas data frame, and then do exploratory analysis using this seaboard visualization library. Okay, so this is real data sciencey kind of set of tools, right? This is definitely, if you're coming from the Power BI world, you probably wouldn't touch this type of stuff very often because you're already doing your visualizations in Power BI. But this is these sorts of tools is what data scientists are used to do their data visualizations. For those of you that aren't familiar with it, so that's cool. It's going to be good. All right, has this run? It has run. And if I hit the refresh button, I feel like there should be like a refresh button here. I want there to be one here. Can I? What do I do to refresh? Refresh. Will that work? There it is.
And for people who aren't used to the kind of data science workflow, the cool thing is that you can actually output these visualizations underneath, like in your notebook. So they'll actually render in the cell below your notebook. So you can kind of explore the data as you go before you pull it into Power BI.
Absolutely. Yeah, and that's kind of the thing, is that it's really great for this kind of data exploration stuff. And if you want some hacks on how to do that with Python and ChatGPT, then Michael's got a nice little video on that whole scenario. So check out Michael's stuff. Michael, put a link in the chat for people. All right. Okay. So I guess we just check this out now. It's all working. We got our table. We could have a look at the table in the lakehouse. Here's the table. Loading. It's still setting up a SQL endpoint, which is the data warehouse kind of view of the lakehouse. Here's our table. So we've got vendor ID, a pickup date, a drop-off date. So this is a taxi database. So for those of you that are unfamiliar with the New York City, it's literally taxi trips in New York City. So you've got a pickup, a drop-off, how many passengers, how long the trip was, the lat and long of each of the trips. And we can create some cool maps and stuff with this data set. Rated code, the fare amount, was there any extras, was there any tax, all that kind of stuff as well, year and month. Okay, so this is a big data set. It's going to have millions and millions and millions of rows. I don't know how many that is in the 2016, the one that we're looking at right now, but I guarantee there'll be a lot. Okay, so we're going to copy this. We'll go back to our notebook. So we can multitask in Fabric down here with our little multitasking business here. I don't think I've really spoken about this. This is kind of new to Power BI, is that you've got multiple artifacts open here at the same time, right? You've got your lakehouse open, we've got our notebook open, we've got a report open, we've got workspaces open. And so this is kind of good, so you can swap back between your different things. I think that was kind of necessary to be able to make this work. So we've got still got our notebook up, ready to go. We haven't really saved this notebook or anything, but we clicked off it and came back on it, and so we can kind of multitask that way. Okay, so we're going to add some.
So
Yep.
on the notebook thing, is there an easy way to rename it while you're in it? I haven't worked out how to do that yet.
Up here.
Oh, just up there. Okay, cool.
Yeah. So we can call this DS Notebook 1. And so that's our naming thing. Yeah, it's always usually the sort of the title is renameable. That's pretty common these days in Microsoft tools. All right, I've got a new set of code. This bit of code reads the table from our tables, New York City taxi raw. It sets a seed of 1, 2, 3, 4, and then it creates a sample, pulls a sample, and it sends it to pandas. So that takes it from a Spark data frame to a pandas data frame. Feel free to chime in if you know about the difference between a Spark data frame and a pandas data frame, because I cannot talk to that. I am not a Spark or pandas expert. Okay, import required libraries and functions for the visualizations and set seaborn parameters. Okay, so with the next little thing we're going to do when that's finished running, I love this iterative way of working. It's so cool. Like, I loved it when the whole reason I got into Power BI because I discovered Power Query, and I was like, Power Query, the way it iterates over data, I just love that. And then this whole iterative way of working in Spark as well. I really like it because you can go back, you can fix stuff, you can run it and see the output. Yeah, it's cool. All right, so in this piece of code, we are, what's going on there? Tick location. Okay, let me try again. Okay, we are importing some Seaborn stuff. So that's importing the Seaborn library. We're importing matplotlib library, the pyplot and tickers. We're importing NumPy. Don't know what NumPy is. What does NumPy do? Anyone know what NumPy does?
Yeah, NumPy actually. NumPy, so that allows Python to be able to compute mathematical things, basically. So
NumPy. Okay, yeah, that makes sense.
Nearly anything you do in Python for our work, you need NumPy added.
Yep. Feel like NumPy's better than NumPy, but we'll go with NumPy. All right, since it's Python. All right. Okay. SNS.set theme. So it sets setting this Seaborn SNS here. It's setting that theme for that Seaborn stuff to be a white grid with a particular kind of palette. This is obviously configuration items for Seaborn, so that you're setting up Seaborn to look right. That might be so that it renders properly in your code view here. It doesn't look weird.
It just makes it prettier. Like the default Python is just like that weird light blue color, whereas Seaborn kind of makes it scale in a gradient. So you can just pick the different theme.
Yep. Cool, we've got a bit more code to put in here. So now what we're doing, we're going to compute our trip duration in minutes on the sample using pandas. So we pulled this table out of our New York taxi dataset table. We put it into pandas. So pandas now has a subset of that, which is only 1,000 rows, right? That's probably for speed and just for the tutorial, right? And then we're using pandas to do this calculation. Okay, so we've got a trip duration, a TPEP drop-off date time. These are column names, right? Trip duration equals the drop-off date time minus the pickup date time as delta 64. That's obviously a type. And it's going to be called trip duration. And if your trip duration is greater than 0, so that's obviously doing some kind of filtering. Then it's putting some plots in. SNS is our Seaborn, so this is now creating the visualization for it looks like. So let's see what happens. Ooh, look at that. We got some visuals. Our trip duration in minutes. So here we've got over 3,000 trips that are very short, and then it drops off over time. And then you can see the kind of distribution of trip durations all the way. And then you've got one here that looks like somebody went to this is on a logarithmic scale. Oops. Somebody went from New York to bloody LA or something. Took it forever. All right. Okay, we're going to do some binning now. So we want to make this a little bit more readable, I guess, or whatever. So let's create that piece of code. Well, where do I add it? Does it go here? Oh, there. It's invisible where this new code button appears, and so you have to guess. But it looks like it. What do? You go to the very bottom of your visualization and drag down, or if you get to this code window, it's just below the code window. So yeah, so that's something worth noting. All right. Bins and trip duration column. So we're going to bin each one. So if it's between 0 and 10, it's going to be less than 10 minutes, 10 to 30, 30 to 60, 1 to 2 hours, 2 to 4 hours, greater than 4 hours. Pretty standard kind of binning thing. And then they're going to plot a histogram using the binning, using our Seaborn stuff. All right. So this histogram plot is a Seaborn. So let's see what that looks like. So this is a bit more data sciencey kind of way of working. If you're used to Power BI, obviously you'd be do your binning potentially in Power Query, and you'd be dragging it in to visualize it. But you can see if you know these libraries and you know this code, you can very quickly generate these visualizations and get an idea of what this data looks like while you're doing it. And this is much more in line with the data science workflow.
Except that it screwed up the x-axis.
Did it? What? Oh, sorting order? Is that what you're?
Yeah.
Yeah, sorting order's always interesting. But I mean, Power BI will do the same thing, right? If you have a sorting order and you don't set the sort order. So it's probably just a thing that we can set here. Be interesting to know, but I'm not going to learn that right now. All right. Looks like, yeah, so it should be like a nice kind of curvy type thing. Oh no, it would be a drop off like this, wouldn't it? So most are less than 10 minutes, or 10 to 30 is the most common. 30 to 60, and then greater than 4 hours. I'm not seeing any, but we had one that was like, someone was saying 16 hours, right? It is a long time in a taxi. So that one's not appearing in our little histogram. But anyway, that looks the same as the picture I've got here. So that's all good. Okay, now we want to visualize the distribution of trip duration and trip distance and classified by passenger count. So we're going to create a scatter plot now to show us the distribution of the two, duration and distance, classified by passenger count. So understanding how many passengers and how long and how far. So that's this bit of code. Drag down, there it is, hit code, put our new code in. So another SNS scatter plot function this time. Just basically really simple, this one, because it's just putting trip distance in X, trip duration in Y, and passenger count in hue, which will be the color or the shading, I guess. So you get this kind of business happening, which is kind of cool. It's got a weird scale. Oh, because of this one outlier, it's created a weird scale. That's interesting. The data set must have changed slightly, because in their version of it, this big outlier guy doesn't exist. Or maybe I got a different. It was a random set from the source, so it's obviously picked up a weird outlier. That's kind of interesting too. I like it. And then what's this guy here? Now, can I mouse? See, I can't interact with this. Being a Power BI guy, I want to be able to see which one this is, create a drill through, and all that kind of. I can't do that, right? So
You've just got to learn Python.
Got to learn Python, man, and then I'll be able to do it. Boo, says Lance. All right. You could easily do all this stuff in Power BI, though, if you preferred to use that for your data exploration, right? That's 100% you could do that. And all right. Visualizing the overall distribution of passenger count column to understand the most common passenger count instances in the trip. All right, so this is another visualization. So this time we create another histogram. So that's hist plot. See, I'm learning. That's a histogram. This is the X and the stat. This is the title. This is the label. This is the other label. So you, by using code to describe, to basically what you would normally do in Power BI on the right-hand side underneath your visualization, where you're changing all of the different parameters, you're basically just writing code to do the same stuff. You just need to know what those code things are. So each, like the hist plot, will have different parameters compared to, say, the scatter plot. We've had no trips with 0 passengers, which kind of makes sense. We've had a lot of trips with 1 passenger. We've had quite a few trips with 2 passengers, and then it scales down from there. But then 5 passengers is kind of common. That's interesting. In a taxi, But how does 5 passengers work in a taxi? It's got to be a big taxi, right? Yeah. Interesting. All right. So that's our distribution of passenger count. We're being scientists here. We're doing science. All right. The threshold. Okay, so this is now, we want to create some box plots to visualize the distribution of the trip duration by passenger count. A box plot is a useful tool to understand the variability, symmetry, and outliers in the data. So we should see an outlier, right? Or maybe we don't have a passenger count outlier. Oh, look at these box plots. I do like a box plot, but I'm not so sure about these ones. Oh, it does look similar to what they've got. They've got a lot more zeros. It's kind of interesting too. Okay. So this is the min and the max and the median and the mean and all that kind of stuff. Do like a box plot. Okay, so this is the distribution of trip duration by passenger count. This is with the outliers removed. So it considers all these guys at the top here outliers, right? And so it takes them all out so that you get a better view of that bit down there, because obviously you can't really read that. So it does this removal of outliers, and then you get this nice, well, nicer visualization, I guess. Yeah, so there you go. Little bit of work there. So how do they remove the outliers? Is there something special they do? What are they doing here? Clean, DF clean, sample DF, passenger count greater than 0, or the trip duration is less than 189. Oh, so does it, they don't dynamically calculate the outlier. They literally just filtered out anything lower than 189. Oh, what a shame. It'd be nice if they dynamically calculated it for us. We're all data scientists. Okay. Let's do some more science. Okay, this one, we're going to analyze the relationship of the trip duration and the fare amount classified by the payment type and vendor ID using a scatter plot. So we're going to create a scatter plot. Here is scatter plot 1 and scatter plot 2. This is going to be fare amount and trip duration classified by payment type, and this is fare amount and trip duration classified by vendor. And it's going to be a couple of different scatter plots. Ta-da! So the payment type one gives us this guy. That's pretty cool. We've got this weird little outlier here. Then there's all these outliers at the top. And you've got these two guys over here on the right. So that's one. What does that say? That means they use payment type 1. I'm not sure what the payment types are. I could look those up. So, and then, oh, look at this guy. There's this guy here and then this guy here. Payment type 3, but they got a refund. The fare amount was minus $50. So the taxi driver paid them. Okay. And here the fare amount was really high and they used payment type 1. So that'd be interesting to know if that was like cash, right? So people who take long trips use a mixture of payment type 1 and 2. People who take short trips or get refunds use payment type 3, because they're all in the negative there, except for that one there. Okay. Anyway, if only we could interact with it. I've got to learn Python. All right. Let's do more science. We're learning science. Okay, now we want to analyze the frequency of the taxi trips by the hour of day using a histogram of the trip counts. So how frequent by hour of day? So there's hour 1 through 24, I guess. Let's see what this code looks like. Right, so we've got hour, day of week, and day name. And it's picking up this sampled DF is our data frame, our pandas data frame. This is our column name, and then this is converting it to hour, it looks like. Converting it to day of week, day name. Then SNS is our histogram, so that's our create a histogram with hour and count. Discrete equals true, KDE equals true. Not sure what those parameters are, but that's okay. The title is distribution, the X label is hours, the Y label is count of trips, and then say show. All right. hit go. And then we get this guy. This is cool. So the stat is the count and the X is the hour. 1 through 24 was hour 0 through hour 23 is what they've done. So this is 12 midnight. And then this is the counter trip. So the most popular time for taxi trips, 5 in the morning is the least popular time. Kind of makes sense. Most popular time is 15, 16, 17, 18 o'clock, 6 o'clock, just after work. That makes sense too. Oh, there's a numeric. Thank you. Someone put in what the payments are. 1 is credit card. Let's go back here really quickly. 1 is credit card. 2 is cash. So this is credit cards down here. 3 is no charge. Oh, so they didn't get charged because the fare amount was negative. Yeah, that makes sense. 4 was disputed. I don't see any green disputed ones. 5 was unknown and 6 is voided trip, and we didn't have any of those in our samples data set. There must be a 4 somewhere because otherwise it wouldn't show 4. So there must be a dispute. Oh, there it is there. It's hiding, but you might be able to just see a little swifter of green there. That's where the disputed fare was. There you go. And it looks like the disputed fare ended up in a negative charge, so they had to cost them money. I guess that's what that means. So if you say no charge, it results in a negative value. So you did a $60 trip, but you didn't charge them, so you got a negative 60. That makes sense. Okay, things make sense. All right, so that's cool. You can do like a cool histogram type situation. Now we're going to analyze the average taxi trip duration by hour and day using a seaborne heat map. So the first thing we need to do, oh, this is fun. Let me give you the code and we can have a look at it. So the way this works is, the first thing they do is they create a pivot using pandas. So it's got this group by and a pivot kind of situation. So it creates a pandas pivot table by grouping the trips by hour and day name columns. So that's these day name and hour columns here. And then getting a mean or an average of the trip duration. So that's what the dot mean trip duration is. The pivot table is used to create the heat map. So you're generating the pivot table and then the second part of the code generates the heat map. That's what this guy does. All right. And then you get a very nice looking visualization. I do love a heat map. That's pretty quick too. I guess it's only 1,000 rows. All right. So now we can see on Friday at 4 o'clock, 16 o'clock is 4 o'clock. Yep. That's our average trip duration. Friday, 4 o'clock is your longest average trip duration. Everybody going out. Thursday after work, lots of taxis happening. Your light time of day here is your Sundays. No one's really catching taxis on Sunday. It all makes sense. My goodness. The science we're doing, people. The science. Negative fare when the taxis drive backwards. Yes. Must be it. Thank you for putting all the stuff in the chat as well, Shelley. That's awesome. The KDE plot is a method for visualizing and distribution of observations in a data analogous with a histogram. KDE represents data using a continuous probability and density curve in one or more dimensions. So that must be this KDE business here. That's why it had KDE equals true. Yes, very scientific. All right, let's hit some code. Okay, finally, this is the last one. So we created a bunch of visualizations here, which is so cool. All right. We're creating a correlation plot useful for exploring the relationships among numerical variables in a data set. It displays data points for each pair of variables as a scatter plot and calculates the correlation coefficient for each pair. The correlation coefficient indicates how strongly and in what direction the variables are related. So let's have a look at this code. Columns to correlation. So it's doing this, get all these columns, and then .core uses this .core function to do the correlation, I guess. Annotation equals true, FMT equals .3f, so that'll be float, 0.3 float. Not sure what that indicator does. And CMAP equals blue. Here is our correlation plot. This is very sciencey. Look at it. So it shows us what has a strong correlation. Positive correlation means that the variables tend to increase or decrease together. So trip duration always increases when we increase trip duration. That is a strong correlation because it's correlated with itself. So that's why you get this one dragging down the middle here. Here you've got trip distance is strongly correlated because that's almost one with fair amount. So the longer you go, the more it costs. That also makes sense to me. So then fair amount and trip distance is repeated over here. Then the next most strongly correlated things are fair amount and trip amount. Tip amount, not fair amount. So the higher the fare, the more likely there's a tip as well. Also makes sense. So when you're a data scientist and you're sciencing some data, what you do is you run these correlation maps. This is really important for machine learning algorithms, because what you do then is you say, well, okay, these strongly correlated columns, you want to add them into your model, right? Because they're the ones that are going to give you the most accurate results. So you want to use the model to train on strongly correlated stuff. That's why they do this type of correlation mapping. Now you look at the negative correlations as well, and you potentially can remove those from your training model so that you're not skewing the data based on negatively correlated things that don't relate to each other. So there's only some slight negative correlations here. What's the highest one? 1.13, 0.18. 0.18 is the highest negative correlation, which is tax and fair amount. So the amount you pay in your fare doesn't necessarily correlate with how much. I assume this is tollway tax or like motor MTA tax. It'll be some kind of toll thing.
Flat fee. It's like a flagpole flat fee.
Ah, MTA. Okay, cool. MTA is automatically triggered based on the metered rate in use. There you go. Okay, so they're slightly negatively correlated, but not super bad. Okay, so that's how these maps work. They're really cool, interesting maps to do. It's very sciencey. So we've got a bunch of visualizations now against all of our things, and we can make our observations based on our science that we've done. So you find out things that, mostly some of the trips have a passenger count of 0, which is a little bit weird, but most trips are between 1 and 6. Trip duration column has outliers with a comparatively small number of trips having a trip duration of greater than 3 hours. So we see that you get these long trip durations. They say that vendor ID 2 has an unusual number of weird trip durations. Let's have a look at that. Here's our vendor ID. So number 2. So look at all these trip durations here. Right? What's vendor 2 doing? Okay, that is causing these large long trip durations. And so those outliers are specifically related to that vendor. Some trips have 0 trip distance, and hence they can be cancelled and filtered out from the modeling because we don't care about the 0 trip distance. A small number of trips have no passengers and then can be filtered out as well. Our fair amount contains negative outliers, which can be moved from model training. We've seen these negative outliers here. There's the negatives. The number of trips starts rising about 4 o'clock and peaks between 6 and 7 o'clock, which we saw in our durations here. So there are our observations that we made, our science. Pretty awesome. Verifone, number 2. There you go. Verifone. What are Verifone doing? They're the vendor number 2. All right. So now we need to do some cleansing so that we can do our Apache Spark stuff. The New York City taxi dataset contains 1.5 billion trip records. This is a serious dataset, people. We're not mucking around here. Okay, we're going to just demonstrate how to use Apache Spark notebooks to clean and prepare the taxi data set. Spark's optimized distribution engine makes it ideal for processing large volumes of data, like 1.5 billion rows. For data sets of a relatively small size, use the Data Wrangler UI, which is a notebook-based graphical user interface tool that provides interactive exploration and data cleansing experience for users working with Pandas data frames on the Microsoft Fabric notebook. What is Data Wrangler UI and where is it and how do I get there? We need to look this up. Is that what I'm just doing now? Is that what they mean? Data Wrangler. Accelerate data prep with the Data Wrangler. Here we go. Launch the Data Wrangler. It's in preview, yeah. Data Wrangler is only Pandas data frames. Well, that's what we're working with. Import Pandas data. Launch Data Wrangler. So confused. Users can launch Data Wrangler directly from a Microsoft Fabric notebook to explore and transform any Pandas data frame. Does that mean I could do it? Is there a launch view, launch Data Wrangler? I can't see it. Language. Okay, we're going to learn about that. I don't know where that is. There's something called the Data Wrangler.
Is it under the data tab, maybe?
Oh, data. Yes, yes, you're there. Preview data wrangling. Clean and transform your data in an isolated environment. Once you're done, you can export the generated code or data set.
Oh, that's cool.
Let's launch it. What's going to happen? Select your Pandas data frame. So these are all the ones that I created during this notebook here. That's why it's, so I'm just going to launch sample DF. God, I just had no idea this even existed. Okay.
I'm blown away. This is awesome.
So you can do operations, drop rows, drop fill, and convert text to capital. So you can do Pandas transforms with this Data Wrangler if you're not doing bazillion rows. There's 5,000 rows here. Wow. Oh, look, we get column distributions, mate. Well, we learned something. See, Friday lunch and learn. We always learn. All right, that's amazing. Data Wrangler, but we're not going to use Data Wrangler today. We're going to ingest data into the lakehouse using Spark and all that kind of stuff. All right. What do I need to be able to do this? Data Wrangler. Wow, I just can't. My mind is blown. Gives you a Power Query-like experience that you can export back to a notebook as Python code. Oh my God, I've got to learn that. I'm going to be the grandmaster of data wrangling. Also, I love data wrangling as a term. It's like the data cowboy. I'm going to wrangle me some data. All right. Okay. All right. I'm catching up to myself. Load using Spark Read. So we're going to create a whole new, I think we're creating a whole new notebook. Yep. It's a dancing cowboy gif. All right. I digress like always. Let's create a new notebook. Oh, did it save that? Like I had no, oh, it did save. Or did it? Oh yeah, DS Notebook 1, here it is. So it does save the notebook. Like I just completely created a new notebook without even thinking about saving them. So I'm glad it saves it automatically. All right, here's our new notebook. We're going to put this in. New York Taxi _DF equals the spark.read.format delta load tables. So we're loading, this is DF always stands for data frame in the Spark world. We're creating a new Spark data frame. It's going to read in our table of data. Go. We're going to use the summary feature of Spark to do this for us. It's going to take a little while to load this into our data frame, I assume. One of the things that's interesting about Fabric that you might not have noticed, and I guess Spark people will have noticed this, but potentially like people who haven't seen this stuff before. Normally when you start Spark, it takes like a couple of minutes to spin up a Spark environment. Because the way Spark works is it's like a bunch of compute nodes, right? So you're spinning up, think of it as like you've got, say, a bunch of bots that spin up and process the data for you. So they've got to turn on and then spin up and get and load. It's like turning on when you first turn on your computer, right? They've got to start and then initiate what they're doing, and then they run. And so in things like even in Synapse or in other Spark tools, you've got to start the cluster, or you've got to start your Spark instance to get it going. And it says, yep, no worries, warming up the cluster, and it's getting everything going. And that might take a minute, might take 5 minutes. Sometimes it can take longer, right? The way that they do this is that in Fabric, they have a Spark cluster that is always running, that is attached to everybody's kind of, to their Fabric sessions. And so it just throws it in as a job into an existing already running Spark cluster, which means you never have to wait for that spin up to happen. It's a shared Spark instance that's always running, which makes it much faster to do these types of things. So I just thought I'd point that out because I thought that was really interesting.
Yeah, it's fantastic. I mean, it would be interesting to see how it turns out when we start paying for Fabric.
Yeah, what the response times and stuff are like. Yeah, I'd like to think that they're going to keep it. It makes sense to do it this way, so I'd like to think they're going to do it that way. But yeah, we'll see. Okay, so this piece of code is going to set a summary. Sorry, go Michael.
Yeah, that's going to be a real game changer for, like, it's so annoying with Databricks having to wait 5 minutes for your cluster to start up every time, and then if it expires, and you're then waiting for a minimum of like 10 minutes unless you manually shut it down. So yeah, it'll be a real game changer.
Yeah, 100%. Okay, it's doing a summary, a dot summary of our data frame. So this is going to display here at some point. Generating summary statistics, it's computationally expensive because it's got to summarize the whole table, depending on how big your data frame is. So this could take a couple of minutes. So we'll see how that goes. The summary gives us like a bunch of different stats about what's in the table. So it's a good way for us to see quickly how big the table is. So we'll give it a couple of minutes to do that. Man, I'm still blown away by that data wrangler. I just feel like I just discovered a whole new thing that. Kicking on from here, we are going to, so we'll have a look at the summary. Then what we're going to do is we're going to clean the data frame. I don't know if we're going to get to the ML stuff today, maybe. Yeah, it looks like it's next. Shouldn't take too long. As long as none of this stuff takes too long to run, then we should be fine. Running. Okay, they say it's going to take between 2 and 5 minutes. Oh no, 2 and 3 minutes or something. What does it say? 2 to 3 minutes, yeah. So we're at 2 minutes now. Hopefully it's a good time where all the Spark cluster is running nicely. So see, we can do all this stuff without having to think about spinning up Spark at all, which is this is the difference between kind of Fabric and other tools right now, is that you don't have to think about this stuff, which is great, particularly if you're just getting started in it and you want to play around. And like look at Michael's thing using ChatGPT and this stuff as well, right? Because I can just see that being so powerful, where you've got ChatGPT and you're asking it to do things and it's helping you generate Spark code, and then you're running it and you're seeing the output, and then you can do all this kind of stuff really quickly without having to and not just quickly, but also super powerfully. Like this will run over billions and billions of rows. It does stuff that Power Query just cannot do, right? You'd be pulling your hair out if you're trying to do some of this stuff on this data set with billions of rows in Power Query, right? It's going to take forever to run because you've got to load it all in. Then say you wanted to do joins and things like that. It'd be horrible. So this is where when you're doing serious data wrangling, this is going to be the way to do it for sure.
And I would add, one of the really cool things about Spark is that it's really quick to return like the first 1,000 rows, like when you do a preview. Whereas with Power Query, especially if you're doing like a non-foldable source, every time you click a new step, you have to wait for it to go and reprocess all the old data again. Whereas Spark kind of does its own execution in the background and everything's in memory. And so it just returns that summary really quickly.
Yeah, it's like, and it holds, because we're running it iteratively, it holds that data frame, so you don't have to go back and redo. So there's so many advantages when you're dealing with larger data sets to approaching it this way. And Taylor says, wait until Copilot. Well, exactly right. There'll be some kind of Copilot experience over here on the right-hand side, and it'll just be writing all the code for us, and we'll just be like, make the table look pretty now, and it'll, like, it would be awesome. So. All right, 4 minutes and 18 seconds is running a little longer than they suggested it might take. But anyway, we'll see how we go. Hopefully it won't take too much longer. Maybe I'll show you a preview of what it's supposed to look like. I've got it here.
Were we supposed to summarize the whole table or just the sample?
No, the whole table. They're doing the whole table.
Yeah, okay.
Yeah. They're keen. They're keen. They do say it's going to take a few minutes, but they did say 2 and 3, and not. We're officially going to hit 5 minutes. That's a long time. Here's what the sample's supposed to look like, and then hopefully when we so you get this, right? You get a table, and it says the count. I just I zoomed in on the wrong thing. All right, over here. Where's my mouse? Okay. So you get your count, your mean, your standard deviation. Okay, get good at zooming, Greg. Right. Count, mean, standard deviation, your min, your different things, and then your max. So your 25%, your 50%, your 75%. Words are failing me, but percentiles. Thank you. And for different columns. So you get, so this has got 4.46 million rows for passengers and trip distance. Wow, it's a lot of rows. 46 million. And then, okay, let's see if it's finished while I play for time here. Hey, it's finished. All right. So there's our count, 46 million rows. Here's our mean. Here's our standard deviation. Here's our percentiles and our min and our max. We can scroll across and have a look at the different things. And we'll. Oh no! What have I done with my thing? My special. Here it is. Okay, take me back to here. All right. And here. All right. Okay, we're going to clean this data frame now. So we're going to clean this table up. We're going to add some derived columns, convert the date time. So we're going to convert the pickup date to the right date time. We're going to have the weekday and the weekday name, the day of the month, the pickup hour, the time duration. We're going to bin the time durée, bin the time of day. So we'll have time bins. We're going to add the fair amount between 0 and 100. We're going to make sure the trip distance, so we're filtering out the trip distance is greater than 0. So we're doing a bunch of filtering and a bunch of calculated columns all in a single piece of code, right? So that's what the next piece of code is going to do. It's doing all of our cleansing, data cleansing, all in a single piece of code, right? So it's saying this dot with column is creating these new columns, and this dot when is going to give us all our filter conditions, right? So we're going to run that. And that has literally just run in 493 milliseconds, just a little faster than the previous one. It says here that Apache Spark uses the lazy evaluation paradigm, which delays the execution of transformations until an action is triggered. It allows Spark to optimize the execution plan and avoid unnecessary computations. In this step, the definitions of the transforms and filters are created, but the actual cleansing doesn't happen until it's written in the next step. So all we did here was set these filters and transformations up. That's why it's so fast. Okay, because it's setting it up, and it's not actually going to execute it until we tell it to output this data somewhere.
Yeah,
So
it's similar to the query folding in Power Query. So
Yeah.
it'll wait until everything is applied across all the different things. It's not until you go select star from
XYZ table, it's going to give you the give you the output. Okay, so now we're going to create this at New York City taxi prep table. It looks like we're going to write this to the Delta table. We're going to write this back to our tables area here. So we're picking up our raw, we're writing we're doing our transformations, and we're writing it back in to the back into the data, into the lakehouse, so that we've got a cleansed version of our table. How are we going for time? 12:58. Oh my God. Can we do this, all the data science in a few minutes? Well, let's see. Let's have a look at. Oh, this is pretty long. Oh yeah. There's batch scoring and saving predictions. I'm just running through to see how many more steps we've got, and then a Power BI report. I think we might have to do this next week. I don't know if we've got time to do it all. Let's wait to see how long this takes to run. I think we'll do the machine learning next week. Sorry if you are here for the machine learning only and you only just, this is all stuff you've already seen, but it just took us a little bit too long to get to the data prep stuff finished.
That's
All
right.
right.
We all learned about data wrangling. So
Yeah, that's right. We learned something as data wrangling. And then next week we'll learn about cool machine learning things. Yeah, because we're going to do quite a few machine learning bits. We're going to do some prediction and batch scoring. We're going to do these, oh mate, there's hyperparameters and ML things, and yeah, it's pretty involved. So I don't want to get training and registering our machine learning model. Yeah, I don't want to get too caught up on that. All right, so let's refresh. This is a nice natural break in. We've got our unidentified table. It's still coming good. Let's refresh again. It should hopefully turn into a prepped data. Here it is. Okay, we'll load it to Spark. You can drag and drop the table into the notebook. That's cool, and it creates a thing that'll have a look at it. We could do that, but I'm not going to do that. I'm going to have a look at the lakehouse view. I'm going to have a look at our prep data. I'll tell you what, to finalize, what we'll do is we'll visualize this in Power BI, this prep data, because why wouldn't we? Okay, so here's all the prep data. Create a new data set. Will Data Wrangler have the information of Power Query and the performance of notebooks? I don't think so. Well, let's have a bit of a look at Data Wrangler as well. Let's use our prep data. What I'd really like, my dream, and this is a dream I've had for a long time for Power BI, is the Power Query UI and notebooks happening kind of in the background. So the Power Query kind of where you can say, hey, I want to drag the clicky, draggy, droppy kind of thing. And it's generating notebooks in the background that are running against Spark instances, because that gives you the best of both worlds. The UI front end, probably the best data transformation UI and the best data transformation capability, both on top of each other. That'd be sick. And maybe Data Wrangler will eventually turn into something like that, but it didn't look like it. We'll have a quick look and see what's available now. Are there links to the previous Fabric sessions available? Yes, there are. I'll put the YouTube. It's all on YouTube. Matt, put it in the chat. If I can look at my subscriptions. Oh no, they've changed the YouTube UI and now I can't find anything. Oh, well, someone will have the YouTube. Someone put in the chat. Shelley's always good for a YouTube link in the chat. Thanks, Shelley. Here's our data set. Let's create a scatter plot. What did we have? The total amount and the trip duration. And it was by passenger count? No. I can't remember. That was trip distance and trip duration. Oh, was it amount and trip duration? Where's vendor? Vendor ID. Values by. Is there an ID in here? Trip ID? Yo. Location. There's only 2 locations. There's only 2 vendors. Anyway, how many rows is it? That's the first thing we need to know. I really want to just count the number of rows. Ooh. I don't know how to do anything in this. Do I have to create measures when I open the data model? Okay. I'm still learning. New report, new measure. Here it is. Total rows equals count rows. NYC taxi prep. Now that report I was working on, oh yeah, it's still there. Cool. Can I edit the data model and then refresh and then it saves it here? I'm trying to learn how to use this business. Oh, total rows, it has appeared. 46 million, okay. Guess that doesn't matter. 46 million rows. Do we have those time bins? Pick date, pick up hour. That should be in the x-axis. So it's pretty responsive, right? 46 million rows, and that's, so we're not, this is direct lake again. So we did a little bit of this last week. This is directly over the, and we get all the same functionality basically of import and direct query. So this, as soon as we update that data inside the lakehouse, it's going to immediately be available here, and it's nice and fast. So I really like that. That is cool.
Impressive.
Yeah, very impressive for sure. Thanks, Shelley, for putting that link in. Distance and amount. Oh, someone was, yeah. I'm hacking it here. All right. The last thing I wanted to look at was a bit more into that thing we learned about, which was the data wrangler. So we do it from a notebook, and then we hit Launch Data Wrangler, which is under the Data tab, and we'll do it on our cleaned sample DF. Oh, we'll just do it on sample DF. Right. This is it. So what can we actually do here? So we can output as a CSV. We could copy our code to the clipboard. Okay. We can add our code to the notebook. Oh, so we generate it using the UI and then add it to the notebook. That's cool. So what do I have here for operations? I can find and replace stuff. Let's do this. Okay. Duplicate rows. How do I do an arrow? That's a line. Control Shift. Is that an arrow? Yeah, all right. All right, duplicate rows, drop missing values, fill missing values, find and replace. Under format, we can convert text to capital, we can capitalize stuff, we can lowercase stuff, we can uppercase stuff, we can transform, we can date time, we can split text, we can strip white space. So it's not quite as nice as the Power Query UI, but there's a lot of the stuff, your standard kind of data transformation stuff's here. So strip white space is like doing a clean or a trim. Multi-label binarizer. No idea what that is, but it's one of the coolest things I've heard today. A one-hot encode and a calculate text length. The UI's all rotated. It is very rotated, isn't it? Also, I feel like I can't scroll down here. This is definitely still in preview. Like I can't, how do I get to the, I can't get to the things down here. I need to minimize and then, it's very, all right. Can someone tell me what a multi-label binarizer, a one-hot encode is, and a one-hot encode is? All right. well, we're running out of time. Maybe we could.
One
Change your
hot
column
encoding, I'm pretty sure, is like a form of vectorizing. So it's
okay.
putting all the textual fields into like one big vector. I'm pretty sure.
Oh yeah, okay. Interesting. Change our column types, drop columns, rename columns, select columns. Yep. We can filter or sort. Okay. We can group by and aggregate. We can create a new column by example. We love column by example. We can scale our min and max values. Interesting. And then our cleaning steps happens here. This is like our applied steps in Power Query, I assume. Loaded the variable. So if I filter, let's just do a filter. The target column, oh man, I'm not loving this ID. Okay, so let's only look at vendor ID 2 is equal to 2. Vendor ID is equal to 2 and hit add condition. No, not add condition. Bin that. Apply. Oh, there we go. Vendor ID equals 2. Apply. And then we get a filter vendor ID down here. Preview code for all steps. Literally just gave us our code here. So, and then it tells us, oh, what's going on with the data was truncated, statistics, okay. So our applied steps is happening here, and then our transformation operations are happening here. It's generating us our pandas code so that we can do our pandas data transformation on smaller data sets. But it obviously doesn't like very big data sets here. But they're trying to build like a Power Query type scenario here for Spark. I love it. I love it. People are putting in one hot encoding. Thank you. I reckon that's where we pull it. So next week, we're going to finish our data science. We're going to finish the science part. We're going to do our machine learning stuff. And then if we run out of time at the end of that, I think that will take the hour or so because there's quite a bit going on. And there'll be lots to talk about with machine learning anyway, because that's always fun. And then once we finish that one, we're going to move into the last one, which is real-time data, which is even more exciting than machine learning. So I'm extremely excited about the next couple of weeks worth. Definitely worth checking out. As usual, thank you all for joining. It's great to see you. We will see you next week. I'll be hanging around to have a chat as always, but if not, have a good weekend, and yeah, we'll see you next week. Thanks very much.